Okay, welcome to 4.5 Notes. And as we stated in class today, the goals for today is to use ASA and AAS to prove triangles are congruent. So before we start, I just want to mention that, of course, if you've written this down already, you don't have to write it again. You can just listen to this at your leisure. You can fast forward. You can rewind. You can pause. So you are in total control. So we'll start off with angle, side, angle. It's the angle, side, angle congruence postulate, which can be abbreviated ASA. So the angle, side, angle congruence postulate states that if two angles in the included side of one triangle are congruent to two angles in the included side of a second triangle, then the two triangles are congruent. So we have triangle ABC with angle, side, angle, and the side is literally in between the two angles. And we have triangle DEF, and again, the side is literally in between the two angles. So the corresponding sides are literally in between, right? They're in between the two angles, just like they would be in the abbreviation ASA. Just like the abbreviation ASA would lead you to believe that the side is literally in between the two angles, so it is in the figure. The side is literally in between the two angles in the figure as well. Okay? So if you have two triangles like that, and you can show that you have corresponding sides, corresponding pair of angles, I should say, corresponding pair of sides, corresponding pair of angles, and the corresponding pair of sides is in between the two angles, then you've proven the two triangles congruent by ASA, and you could say then, for example, in this case, that triangle ABC is congruent to triangle DEF. And moving right along, we now have the angle-angle-side congruence theorem, which can be abbreviated AAS. And the angle-angle-side congruence theorem states that if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of a second triangle, then the two triangles are congruent. So a diagram which displays that is you have triangle ABC with an angle, another angle, and then this is a non-included angle. If it was angle, side, angle, the side would be in between the two angles, right? So that would be here, for example, but that's not the case. It's non-included, which means it's not in between the two angles like that. So that's why this one's called angle-angle side, or AAS. Okay? And so if you have another triangle, triangle DEF, and you have these two pairs of angles are congruent, another pair of angles are congruent, so you have AA so far, and then these two sides are corresponding, right? They're in the same place in the triangles, right? And they're non-included. That means they're not in between the two angles. Then you have a case of angle-angle side, or AAS. And you've proven the two triangles congruent. And in this case, that means triangle ABC is congruent to triangle DEF. Okay, so what kind of problems can you expect? Here's one. What postulate or theorem can you use to prove that triangle RST is congruent to triangle VUT? And explain. And when it says explain, it basically just means to write down the abbreviations for either the postulate or theorem that proves it. So like SSS or SAS or AAS or whatever. But the two that we learned today are ASA and AAS. So just as a guess, since this is today's lesson, this is probably going to be ASA or AAS. So let's just say, for sake of argument, that you think it is ASA. So you have angle and a side. And so what you're saying then in red is you're saying, it must be this angle, right? You want angle, side, angle. So you're saying the side is literally in between the two angles, and that doesn't leave a choice. You're saying it literally has to be that angle. But we don't know anything about that angle. We don't have any information about the measure of that angle. So that's not the situation. So let's explore angle, angle, side. Let's see if that could be the case. Here's angle, and a side, so I need another angle. But like we said, we don't know anything about this angle. But hey, what about this angle? Do we know something about this angle and about this angle? Well, as a matter of fact, we do. We have these two angles are congruent because they're vertical angles. Okay? So, this angle is congruent to this angle because they are vertical angles. Okay? So that is angle, angle, side. So we have angle, angle, side. So what postulate or theorem can you use to prove these two triangles congruent? Answer, angle, angle, side. All right, and let's see. I also would like you to write down page 252 for your notebook. It's on the top of page 252. It summarizes basically all of the postulates or theorems that you can use to prove triangles congruent. And then I also wanted to go over two that don't work. Okay, these two don't work. AAA and ASS. So AAA and then ASS, of course, I'm sure you know, reminds you of a donkey. So just think of like the insurance, AAA, and a donkey. Insure your donkey. You cannot insure your donkey. AAA and ASS do not work. So you cannot insure your donkey. And in class, I went over and I showed you, I diagrammed for you and went over why they don't work. If you have any questions on that or anything else, then please feel free to contact me, and I'm sure I can help you. All right, bye-bye.